Hello everyone. Today we are going to talk about systems of non-linear equations. Before we were dealing mostly with linear equations and systems of linear equations. What are systems of non-linear equations? Let me give you an example of such a system. For example, 3x minus y equals minus 2. This is a linear equation because all powers of x and y are equal to 1. And that's two variables, right? X and y. My second equation is going to have 2x squared minus y equals 0. Second equation is nonlinear. Why it's nonlinear? Because the power of x is equal to square. Nonlinear. The power equals 2. And if we unify these two equations in a system, we are going to assume that solution of the first equation is going to also solve the second equation. That's a typical example of system of non-linear equation. How do we solve systems of nonlinear equations? Same way we do systems of linear equations, either substitution or elimination. Well, I'm going to try to do elimination on this one and maybe a substitution on the next one. So elimination. Elimination means that I'm going to multiply either first equation or second by a certain number and then add them together to eliminate one of the variables. What I'm going to do, guys, I think I'm going to multiply first equation by minus 1. And I'm going to write down like minus 3x plus y equals 2. I'm multiplying the first equation by minus 1. So everything is changing the sign, minus, plus, plus. And I'm going to add it to the second equation, 2x squared minus y equals 0. If I add these two equations, I'm going to cancel y, right? This y and this y are going to cancel to 0. And for x's, I'm just going to have 2x squared minus 3x. And that's going to be plus 0 from y equals 2. And you see that I have now just one variable x, and I'm going to write it down in more convenient form, 2x squared minus 3x minus 2 equals to 0. And that's quadratic equation, which I'm going to solve using the formula x12 equals plus minus square root. And I have 9b squared, right, minus 4a, which is 2, and c, which is minus 2, and then minus b, and my b has minus already, so it's plus 3, and divided over 2a, 2 by 2. And let's see what we are going to have. So plus minus square root of 9, and this is 2 by 2 is going to give me 4, by 4 is 16, so it's plus 16 plus 3, and divided over 4, right? And 9 plus 16 is 25, and the square root of 25 is plus minus 5, right? Plus 3 divided over 4. So there are going to be two roots. I'm going to first combine pluses. So plus 5 plus 3 is 8, divided over 4 is 2. And then minus 5 plus 3 is minus 2, divided over 4 is minus 1 over 2. So there are two solutions, x1 and x2. Well, because we are working with a system, x is not going to be the only answer, right? We'll need to find also y. So for x1 equals 2, what is going to be y? Well, we can use equation 1 to calculate y, right? I'm going to plug in 3 instead of x2 minus y equals minus 2, or I'm going to have what? Minus y equals minus 2, and 3 by 2 is 6. If I move it over here, it's minus 6, and I'm going to get minus y equals minus 8, from where y equals 8. So my first solution is going to be 2, 8. You see a pair of solutions because we have two variables. Now I'm going to plug in x equals 2 minus 1 over 2. So let's see, minus 1 over 2, the same equation. So use equation 1 again, and I have 3 by minus 1 over 2 minus y equals minus 2. Guys, what I'm going to do here, well, first I'll multiply 3 by minus 1 over 2, it's minus 3 over 2, right? And I'm going to move 2 over here and minus y over here, so it's plus 2 equals y. Well, here I bring it to common denominator, which is 2, right? Minus 3 plus 4, multiplying by 2 here and here, and divided over 2 equals y. Or we are going to get 1 over 2 equals y. So my second solution is negative 1 over 2 and 1 over 2. And I'm going to give my final answer as 2, 8 and minus 1 over 2, 1 over 2. Well, again, two solutions just because we have quadratic equation here, right? And the pair of solutions because we have two variables. Well, let's consider another example. And this example I'm going to do with elimination. Okay, so let's do not elimination, substitution, sorry. X squared minus y squared equals 4 and y equals x squared. So what I'm going to do, I'm going to consider equation number 2 and substitute instead of x squared y into equation number 1. So I'm going to use y minus y squared equals 4. So instead of x squared into equation number 1, equation number 2, I'm going to substitute y into equation number 1. Now I'm going to bring everything to one side. I'm going to move everything actually to this side to have positive sign in front of y squared. Okay, so I have a 4 plus y squared minus y equals to 0, or if I arrange it correct way, it's 4, y squared minus y plus 4 equals to 0. Right, and well, let me see if we are going to have any real solutions over here. You know, sometimes equation has no solutions. Let's try to find y12 using the formula plus minus square root of 1, right, square, minus 4, a is equal to 1, c is equal to 4, minus b, so it's plus 1 because it has minus already, and divided over 2a, and a is equal to 1. Okay, guys, if you look over here, we are going to see that the solution is minus 16 plus 1 is minus 15, right? Plus 1 over 2. If somebody is asking us about only real solutions, we are going to say no real solutions because of this, right? But if somebody is asking us about complex solutions, we're going to give some complex solutions. So we remember that the square root of minus 15 is going to be actually plus minus square root of 15 multiplied by I plus 1 over 2. And that's going to be my y, right? Now, how do I find my x? To find my x, I'll need to square my y, right? And that's can be a problem. We're going to do it once, but again, read carefully the problem. If the problem is not asking about finding complex solutions, but asking about only real solutions, you would say there are no real solutions. But for complex solutions, we will need to square it, right? To find actually, oh no, not square, actually, extract the square root. Well, let's do it. I think the idea of doing y first was not a very good idea. I should have calculated x, I guess, but that's okay. We can extract a square root. I hope that you guys still remember to extract. No, we did not cover it here. We're going to do square roots in trigonometry. That's not good. Okay, guys, let's stick to only real solutions then. Here to solve this, we will need to do what? To find x, because this is y, to find x, we'll need to extract the square root of y, right? And unfortunately, we don't know how to extract square roots of complex numbers yet. So let's kind of say there is no solution. So I'm going to stick only to real solutions and say no real solutions. I'm still thinking maybe I did a mistake somewhere and that's a reason why 4 plus y minus 1. I don't know. Doesn't look like I did a mistake anywhere. But who knows? I don't know, I guess. I don't think that I did a mistake anywhere. So means that there are no real solutions. If you could extract square roots of complex numbers, we would do this, but I did not explain it yet. And that's coming in just next class in trigonometry. Okay, sorry. Well, let's solve something else. Next problem, we're going to solve example number 3 is going to be y equals a square root of x and y equals 6 minus x. Well, how can we solve this equation? I'm going to use substitution here too. But first, I'm going to take my first equation and square it to get just x. So my y squared equals x. And then I'm going to plug y instead of x here. So I have y equals 6 minus y squared. So my equation is going to be y squared plus y minus 6 equals to 0. I'm bringing this 6 on this side and minus y on this side. So both are changing the sign. Well, let's hope that this one is going to have a solution. So y equals plus minus a square root 1 plus, because it's a minus here, 24, 4 by 6, right? Minus 1, because it's a plus here, divided over 2, because a is equal to 1. So I have plus minus 5 minus 1 over 2, and plus 5 minus 1 is 4 over 2, 2, and minus 5 minus 1 is minus 6 over 2 is minus 3. So I have two y's, which one is 2 and one is minus 3. Guys, let's look for real solutions so we don't deal with extraction of complex roots. Real solutions. Okay, so now I found my y. Now I'll need to find my x. I know that, well, from equation number 2, I know that y equals 6 minus x, which means that x from this equation equals 6 minus y, right? If you bring x here and y over here, y is going to change the sign, x is going to change the sign. So I'm going to calculate x1 for y1 equals 2 is going to be 6 minus 2, which is 4, right? And y2 equals minus 3, x2 is going to be 6 minus negative 3, which is going to give us 9, right? Guys, sometimes when you square equation, you can get extra roots. And usually you don't want to get them. So makes sense if you are applying squaring anywhere in your solution to check back if your solutions are actually working for your system. So our solutions were 2. Sorry, I should write down first x. So x was 4, y was 2, and my second solution was x was 9 and y was equal to negative 3. So let's check 4 and 2. Does it fit into equation? Well, first, 2 equals square root of 4. First equation checks, right? That's correct. And the second equation, 4 equals 6 minus 2. Well, kind of checks. So this pair is working. Good. Works. How about this pair? Let's use a different color. So I'm going to plug in 9 and minus 3. So y equals minus 3 equals a square root of 9. Well, you know, square root of 9 is equal kind of 3, but not minus 3. Here, guys, when you write down equation, we do mean the principal value of a square root, only one value here, just a positive one. So this one is already not working. Means that this is not going to be a solution, not a solution. So we have only one actual solution. That's a solution. Okay. So again, why did it happen? Because I squared, and when you square something, you can add extra solutions, and that's what happened when I squared the expression. Now, guys, I'm going to assign you 2 problems to solve on your own, and then in 5 minutes, try to check your solution with me. Okay. Self-work. So problem 1 x squared plus y squared equals 10, and y equals x plus 2. And problem 2. 2 over x squared minus 3 over y squared plus 1 equals 0, and 6 over x squared minus 7 over y squared plus 2 equals 0. So let's try to solve these two problems, and I'll give you like sometimes I'll stop my video. I'm going to count to 5 and actually solve them. So 1, 2, 3, 4, 5. Okay, for the first system, I'm going to use substitution, though I can actually use elimination. Oh no, I'm going to use substitution. So I'm going to express from the second equation y equals x plus 2 and put it into the first equation. So it's x squared plus x plus 2 squared equals 10. And I'm going to simplify this expression. So it's x squared plus opening parenthesis x squared plus 2x by 2 plus 2 squared is 4 equals 10. And I have 2x squared plus 4x 2 by 2, right? And if I bring 10 over here, it's going to give me 4 minus 10 minus 6, so minus 6. I'm going to divide all equation by 2, okay? Just I don't like to work with big numbers. X squared plus 2x minus 3 equals 0. I think here we don't need to use the formula. I think we can just factor it x plus 3. X minus 1 equals 0. The product is minus 3 and the sum is plus 2. So two solutions, x1 equals minus 3 and x2 equals 1, right? Each equals to 0, each parenthesis. Now we just need to find y, and I'm going to use this equation to find y. So y1 equals x plus 2 equals minus 3 plus 2 minus 1. y2 equals x plus 2 equals 1 plus 2 equals 3. So we got two solutions. First solution is minus 3 minus 1, and the second solution is 1 and 3. I did not square anything, so that's going to be solution. Okay. So now I'm going to solve the second problem. Unfortunately, I already used a little bit space under the second problem to solve the first one. So I'm going to make a line. So guys, how are we going to solve the second problem? For the second problem, you see that you can try to do elimination. Elimination means that, for example, you have over here 2 over x squared and here 6 over x squared. If you multiply the first equation by 3, better minus 3 actually, you're going to get the same expression for x, but with minus. So I'm going to have something like minus 6 over x squared plus minus 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 over here and minus over here is going to produce plus 9, right, over y squared minus 3 equals to 0. And my second equation is 6 over x squared minus 7 over y squared plus 2 equals to 0. Now I'm going to add these two equations, and the first term is going to cancel each other, right? Minus 6 and plus 6. The second term, 9 minus 7 is going to give me 2 over y squared. And here I have 2 minus 3 minus 1 equals to 0. You see that equation is now about one variable only. What I'm going to do here, going to write down as 2 over y squared equals 1, and then do crisscross multiplication, like multiply everything by y squared here and by y squared here. So I have 2 here and y squared here, from where y equals plus minus square root of 2. Now I just need to calculate x. To do this, I'm going to plug my y into, I don't know, first equation or second equation. Which one is better? I'm going to plug it into the first equation. So my first equation is 2 over x squared minus 3 y squared equals 2. So I'm going to write down 3 over 2 plus 1 equals to 0. I'm going to combine the numbers here, right? It's 1 minus 3 over 2 is equal to negative 1 over 2. So I have 2 over x squared, sorry, 2 over x squared minus 1 over 2 equals to 0. And if I kind of separate 2 over x squared and 1 over 2 here, and then multiply by 2 here and here, and by x squared here and here, x squared cancels here, 2 cancels here. And I'm going to have 4 on this side, 2 by 2, right? And on this side, I'm just going to have x squared, which is going to give me solution x equals plus minus 2. Now, guys, what is going to be actually the answer? Is it going to be like two pluses or two minuses together, or plus and minus? Well, let's look at the structure of a system. So right now we have y equals plus minus square root of 2, and x equals, let me scroll down, plus minus 2. Plus minus 2. So how do we combine them? If you look at the structure of equation, actually my equations are not sensitive to pluses or minuses, because all x's and y's here are squared, right? So actually doesn't matter you have x minus or 2 or plus 2 for y, it's not going to change anything because it's already squared. So what I'm going to do, guys, I'm going to combine first all positive solutions. So 2 and the square root of 2. And they, because they are squared, it's not going to change anything. And then I'm going to do 2 and the minus square root of 2. Well, again, this 2 was working like this 2, right? And if I have minus in front of y, it's not going to change anything. My next solution is minus 2 square root of 2 and minus 2 minus square root of 2. So we have 4 solutions. Why do we have so many? Well, first it's 2 equations, and each variable is squared here. So normally we have 2 solutions for x and 2 solutions for y, but we also kind of have both of them like in 2 equations. So that's going to be my solution. Is it always like combine all possible x's with all possible y's? No, guys, you will need to look back at the equation. For example, if you look at the previous example, in the previous example, each x is going to have its own y. And for example, this x, which is minus 3, this x, which is minus 3, is not going to be combined with this y, which is 3, because they are not going to work together in our equation. If you plug in minus 3 here, instead of x, you're going to get what? Minus 1, and that's not going to be equal to 3. So sometimes we combine all of them, but equation is supposed to be symmetrical, and sometimes no. Okay, that's all for systems of nonlinear equations, and I hope that you will do the homework for this section, and see you next lecture.